Hello and welcome to lesson 2.6 of our geometric proof. This being a little bit longer lesson, if you've taken a look at the notes, you'll discover that there are more examples to cover and the notes will take us a little bit more time. So in order to fit this in and give yourself plenty of time, we are doing the lesson in two different videos. We'll take two different class periods to work on these assignments as well. Let's begin by taking a look at the warm-up for today. We're going to determine whether each statement is true or false. If false, give a counterexample. So, number one, if two angles are complementary, then they are not congruent. Well, if I have two angles that are complementary, that means their angles add up to, or their angle measures add up to 90 degrees, and I can think of a number pair that do add up to 90, but are also congruent. They're the same measurement. That would be 45-degree angles. So this is a false statement. So, false if each angle measures 45 degrees. Number two, if two angles are congruent to the same angle, then they are congruent to each other. So if I have two angles that are both congruent to a same third angle, then they are going to be congruent to each other. That is true. And number three, supplementary angles are congruent. Again, kind of comparable here, but I can think of two supplementary angles that are not congruent. Angles measuring such as 100 degrees and 80 degrees are supplementary, but not congruent. You could have come up with any number pair there. So now that we've done a little bit of a warm-up, let's take a look at our geometric proof lesson, where we will write two-column proofs and prove geometric theorems by using deductive reasoning. This lesson video will be organized a little bit differently. We're going to put all of the vocabulary and theorems and postulates right at the beginning of the video. We're going to go through all of that first, and then we will take a look at examples in the second portion of the video. So first, when writing a geometric proof, it is important to justify each logical step with a reason. You can use symbols and abbreviations, but they must be clear enough so that anyone who reads your proof will understand them. And geometric proofs will generally follow this pattern. We'll start with a hypothesis, a given set of information. Then we're going to go through any definitions, postulates, properties, and theorems that would help lead us towards our conclusion. So we'll make statements and use these kind of things as our reasons. Definitions of terms, postulates, theorems, any of those properties, POEs and POCs. And then our conclusion will be what we're supposed to prove. And this is set up a little bit like a flowchart like you've seen, but once again, we're going to be focusing on the first and foremost type of a proof, and that is a two-column proof today. So, let's first talk about what a theorem is. We've used some before in class, but I want to give you that definition. A theorem is any statement that you can prove. Alright, and if you can prove that it is true, it is a theorem. Once you have proven a theorem, you can use it as a reason in later proofs. So we've got two theorems to start us off. Theorems 261 and 262. These do not need to use the numbers when you're referencing them because they have proper names. The first is the linear pair theorem. It says if two angles form a linear pair, then they are supplementary. Let me remind you of what a linear pair of angles would look like. Okay, if I have an angle here, and then, sorry, that's a ray, and if I have any kind of angles like this that form a linear pair, they are going to be supplementary angles. So we could call this A and this B. A and B form a linear pair, then we know angles A and angle B are supplementary. Theorem 262, congruent supplements theorem, states if two angles are supplementary to the same angle, or to two congruent angles, then the two angles are congruent. So if we were given a situation where angle 1 and angle 2 are supplementary, angle 2 and angle 3 are supplementary, since 1 is supplementary to 2, and 2 is supplementary to 3, we kind of have a transitive property of supplementary angles going here. We could say angle 1 is congruent to angle 3, not supplementary, because 1 and 3 are both supplementary to the same angle. So for example, if the measure of angle 1 was 80 degrees, the measure of angle 2 would have to be 100. That would mean for 3 and 2 to be supplementary, 3 would also have to be 80 degrees. That makes it congruent to angle 1. And then we also have another theorem that we will use later on in the note packet, but this is theorem 263 and 264. Once again, they have proper names, so from here on out we will call them by those proper names. Right angle congruence theorem simply states all right angles are congruent. And that would be a very easy one for us to prove. We're also told the congruent complements theorem. If two angles are complementary to the same angle or to two congruent angles, then the two angles are congruent. This one is very much like this one, congruent supplements theorem. And so we're just dealing with complementary angles instead. So let's talk about what a geometric proof begins with. You will be given two statements, or two sets of statements. A given set and a prove set. The given information is where you start. The prove is the conclusion you're trying to reach. These restate the hypothesis and conclusion of some conjecture. A two-column proof is a form of geometric proof where the steps of the proof are listed in the left column, or the statements, and the matching reasons for each step are listed in the right column. So just a quick recall for writing math: substitution property of equality, since there's no other substitution property, the substitution property of equality can be written in a more short manner as just substitution, or abbreviated SUBST period. Okay, we can just write substitution or this abbreviation. You do not have to put POE after this because there is no other substitution property. Before we start writing a proof, you should plan out your logic. Sometimes you're going to be given a plan for a more challenging proof to follow. This plan will detail the major steps of the proof for you. But regardless of whether you're given a plan or not, you need to come up with some sort of a plan. You can use the parts of a flowchart proof to do so, or you can write it out in sentence form like a paragraph proof. So here's a helpful hint. If a diagram for a proof is not provided, draw your own and mark the given information on it. But do not mark the information in the prove statement. That is what you're trying to show. You can't establish that as given yet. So here is a quick 5-step process for the proof process. Number 1, write the conjecture to be proven. Most of this time, this is going to be done for you. You are given the given information, you're given what you're supposed to prove. Number 2, draw a diagram to represent the hypothesis of that conjecture. The given information needs to be marked on the diagram, if it's not already drawn. Then, for most of our proofs, at the beginning, we're going to be starting with step 3. State the given information and mark it on the diagram. Number 4 is to state the conclusion of the conjecture in terms of the diagram. And then we're going to plan our argument and then put that plan into action and prove the conjecture. So let's try some of these problems. In these first ones, we're just going to practice giving the reasons for the different statements given. So here's the situation. We are given angle A and angle B and told that they are supplementary angles. That is given information. There's not a real good way to mark that. All right, you just know that they're supplementary angles. But you're told the measure of angle A equals 45 degrees. So if I were to start off with statement 1, these two things are just the given information from that sentence. So our reason or justification for each one of those is the word given. On number 2, these are all related. We are taking this statement and telling something else about what we know about angles A and B. Since I know they are supplementary, I can conclude this, that the measure of angle A plus the measure of angle B equals 180 degrees. That's because that is what our definition of supplementary angles states. So the justification for this line, if we're given this, is the definition of supplementary angles. Now, we are also given the measure of angle A equals 45 degrees. That is not included in step 2, but we are going to use that in step 3. But these are all linked together. We go from statement 1 to statement 2, then to statement 3. Statement 3 takes the equation from statement 2, but then we are changing it by replacing the measure of angle A with 45 degrees. Since those are equal values, we are taking one out and replacing it with something that is equal. That is substitution. So that's our justification for that statement. And to arrive at our final statement, we go from this equation to this one. So look at how that has happened. Well, we must have taken 45 degrees from this side and taken it from this in subtraction to get this statement. So this is the subtraction POE. Notice the difference in abbreviations of substitution and subtraction. Please make sure you mark those correctly. Why don't you take a moment or two to come up with the reasons for these statements using this as your starting place. You're given that B is the midpoint of AC and that AB is congruent to EF. All right, so take a minute to try and write each statement in these blanks. All right, let's take a look at this one. B is the midpoint of AC. That is given to you. B is the midpoint of AC. That's a given statement. Then the next statement, this is not given in this sentence, but we do know that AB would have to be congruent to BC. If you want to mark those, you just put tick marks there before you start the proof. So we know AB is congruent to BC because of this statement. That's what we know midpoint means. Anytime you can say that phrase, that's what this word means, you're talking about the definition of that word. So the reason for statement 2 is definition of midpoint. Then because we know this, we go to the next one. AB is congruent to EF. The only thing that tells us that is, again, part of the given information. That's what we're given. So I can write given again. This is one way to write this. We could have put both the givens in the same line, but because statement 2 comes directly from that first given, we link those together before stating the third statement. Now, since AB is congruent to BC and AB is congruent to EF, we can say that BC is congruent to EF. That would be the transitive property of congruence, not substitution. Substitution does not apply to congruence, so we have to say transitive property. So this is how we fill in the missing reasons that go along with the statements in a proof. So for the next example, we are given most of a proof. We just have to fill in what has been missing. Some of them are statements, one of them is a reason. So let's look at this proof. You are given segment XY. You're not told anything else about it, you just know that is segment XY. You are asked to prove that XY is congruent to itself. We are proving the reflexive property of congruence, but we're going to do that in a proof. We start with the given information. The reason is given. I know I have to state the given first. Then I say xy equals xy. Now, the reason for this, we know the length of our segment is xy, and I have the reflexive property of equality, so that can be the reason for this statement. And then the last reason for this last statement is the definition of congruent segments. If I'm told that two segments are equal in length, the definition of congruent segments tells me that those segments are congruent. So why don't you take a few minutes and try and fill in the missing pieces to this proof. All right, let's take a look. We are told our given information is that we have three angles they're talking about. Angle 1 and 2 are supplementary, and we're told that angles 2 and 3 are supplementary. We want to prove that angle 1 is congruent to angle 3. We are proving the congruent supplements theorem. So we start off with the given information, write it as given. The next statement describes that given information based on definition of supplementary angles. We tell further what supplementary means. That means measure of angle 1 plus the measure of angle 2 equals 180. The measure of angle 2 plus the measure of angle 3 also equals 180 degrees. That's all because of the definition of supplementary angles. The next statement has a reason of substitution. So we're taking this and we're substituting somehow. Well, both of these left sides of each equation are equal to 180 degrees. So I could substitute measure of angle 2 plus measure of angle 3 for this 180 degree side. So I can write measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. Now, this proof states next that the measure of angle 2 is equal to itself by the reflexive property of equality. That allows me to take this measure of angle 2 on both sides and cancel that. And we do that by subtracting the measure of angle 2 from both sides. So the reason that we get measure of angle 1 equals the measure of angle 3 is by subtracting the measure of angle 2 from both sides, subtraction property of equality. Well, if the measures of angles 1 and 3 are equal, then angle 1 must be congruent to angle 3. That's just by definition of congruent angles. And that is our proof. Hopefully you've had a chance to be able to understand these videos a little bit more. We will talk more about these in the next video.